Hi, I'm Teacher Im and I prepare videos to help my students score better in their STPM MATH T paper. And I hope my videos can be helpful for you too. Well, let's get to the video and we will see what we are going to learn today. If you get any good values from there, please hit the subscribe and like button if you have not. Well, thank you. Let's get to it. In this video, we are going to talk about matrices and now we are going to talk about our checkpoint 3.2 system of linear equation. Alright, we are going to learn how to reduce an augmented matrix to row echelon form, and then we need to talk about unique solution, infinitely many solution, and no solution for the system of linear equation. Let's get to it. This video is for me to answer one of the viewers in my live session the other day. So, Luis Lau asked, Teacher, why for STPM 2017 question 7 row echelon form the entry 22 cannot be in terms of P? Well, I believe Luis Lau meant to ask why the entry of P cannot be 2 and 3 in that question. So, before I can explain that, I need to explain all the situation needed for getting the entry or the solution for a system linear equation. Alright, so we have three types of solution in when linear equation are transformed into a matrix. Now, the first type is when there is no solution. If a matrix has no solution, you will notice that all the values here will be 0, but the n values here, because the formulas given are 0, 0, k, where k are non-zero constant, which means the n value here can not be 0. It can be any number but 0. Okay, so in this situation, we call this matrix has no solution. This system has no solution. Okay, let's talk about infinite solution. When the system has an infinite solution, you will notice when it transformed into an augmented matrix, you will notice that the n here has all the zeros. It will end with all zeros in the end. Okay, and if the system has an unique solution, when you transform it to augmented matrix, you will notice that at the end row here, the number here can be any number except 0. Okay, it can be any number except 0. And the number in this position can be any number. Okay, can be any number. Well, so with that knowledge in mind, this knowledge I also mentioned when I gave my live tutorial the other day. So if you have not watched that live tutorial, you can check it out in the link below or in the box somewhere around at the top corner there. This is the question asked by Luis Lau. Now, it is a STPM 2017 question 7. Now, in this question, there are a few parts in the question, and the first part has 5 marks in it. And to start with that, we need to transform the system of linear equation into augmented matrix. So it is very easy to transform a system into augmented matrix. So this is augmented matrix. So how does we perform that? So we will check, for example, here x 2y plus z equals to q. So in front of x, there's a number 1. So we write 1, and then we have 2y, so we write 2, and z, there is only 1, so we write 1. And then the last here, the equals to, the solution is q, so we write q there. Okay, once we are done with that, then we will go to the second row. So we have 2x, so we have 2, then we have py, so we have our p there, and then we have 4z, then we write 4. And then, of course, our answer is 3q here, so we will end it with 3q. And that goes the same for that last row. All right, so we will have x, 1x, 1y, so we have 1x, 1y, and we have pz, so we have a p here, and then equals to q, and we have our q here. So once that is done, then our augmented matrix is now ready. So the next part in the question asks you to reduce it to row echelon form. So in my tutorial the other day, I did teach about row echelon form, so you can check out the tutorial. It is a 1-hour tutorial, so you can check it out, and I hope I give good values and good knowledge there, so you can check it out, and I will leave a link up here later in the video. Okay, so we have to reduce this to row echelon form. So I just give a brief explanation. So this is considered the format of row echelon form. Okay, so in row echelon form, you will notice that there will be 3 zeros in the corner. Okay, so we call this or we can also notice that there will be some all the values of 1 in the corner in the diagonal here. Okay, so we will, when you reach this format, okay, firstly of course is the triangle, the 3 zeros here, that is a must for a row echelon form. And then this 1 here are optional, so most of the time we will start from the top, and then we will move along the way. Later, I will talk about the steps that you need to settle this row echelon form. So, but before we go to that, we need to firstly know what are the things that we can do to reduce our augmented matrix into row echelon form. So let's check it out. All right, so to do that, we need to settle elementary row operations. So what is it actually? Basically, what we are going to do is we are going to transform the augmented matrix to row echelon form or reduce row echelon form. You can check it the videos that I mentioned just now. I also did mention about reduced row echelon form. Well, so to get it into row echelon form, we can interchange 2 rows. Okay, so we can take row 2, change with row 1, or row 1 interchange with row 2, and we call that step as swap. And then we can also multiply a row by a non-zero constant. So maybe we can take row 2 and then we multiply by k, and that will give us row 2. So that we call it scaling. Or we can also multiply a row by a non-zero constant and adding or subtracting it from the answer to another row. So we will get an equation and we will write it inside the row. Okay, and this we call it pivot. So with all these 3 steps, we can choose either of these 3 steps to perform on our augmented matrix, the row, so that we can transform our augmented matrix to row echelon form. And this arrow over here means replaces. Okay, so whatever we want to calculate will replace the place for row 1 if we have row 1 here as an example. Okay, once we know that, we will continue with our steps. Now, to perform this into row echelon form, most of the time I will suggest to my student to follow these few steps. So I will start with with the first step and go on with the second one. So for the first place here, I will change it into 1. So follow this format. It should transform to 1. And then for the second step, I will need to transform the number to 0. And for the third step, I will transform it to 0 again. And then we will go to the fourth step, which is the center here. We will transform it into 1. And for the fifth step, we will want to transform the augmented matrix to 0. Okay, the values here. And then when we go to the sixth step, that will need to transform into 1. So once we get one whole row of 1s and 3 rows of 0s, then we will already reach our row echelon form. But however, if we want to get into reduced row echelon form, we will follow up with this number 7. Okay, we will transform that to 0. And step number 8, where we transform it into zeros also, and step number 9, which also will be transformed into 0. So once we get that into that format, then we call it the reduced row echelon form. But today we only need row echelon form, which means we might stop at step number 6. Okay, or when we already reach 3 0 at the end in the corner here, as so. All right, so I'm going to go to the first one. Okay, so the first step that I have here, I notice is already 1. So I can skip step 1 and go to the second one. So the second one, that my target will be transforming that one into a 0, that number 2. So I always tell my student that I need to target what I need. So I know that I need to transform it to 0. So I will place it into 0 there first. And then I will copy the rest of the rows so that I know that I have that already fixed and I do not need to think about them. Okay, so now my target. How to transform 2 into 0? So we choose a formula and we write down the formula. Okay, we choose 2 times row 1 and then minus with row 2, then I will get 0. So 2 times 1, row 1 is here. So 2 times 1 is 2, 2 minus row 1, row 2, sorry, that will give me a 0. So now I already fixed that formula. So just in case you don't do much mental calculation, you can build a box like this, or you can just roughly sketch something like this. Okay, this is actually this part here, the working here are optional. You do not need to show it during exam, but if you find that when you create numbers and those numbers are very irritating and you find it very hard to write the correct number and you want to play safe, okay, actually this box here, the numbers are for you to play safe so that when you fill in, you won't fill in the wrong numbers. Okay, so what actually happened inside this box? So I will take my row 2, 2 multiplied by row 1. So my row 1, usually I will ask my student to look at the original augmented matrix. So my row 1 is 1, and then 2 times 1, I have 2, and then 2 times 2, I have 4 here, and then 2 times 1, I have 2, 2 times q, I have 2q. Minus by row 2, so I will copy everything from row 2 into the box here, and finally I need to do the subtraction because it's row 2 or 2 times row 1 minus row 2. So I will take the top minus the bottom, so I will get these answers over here. The zeros, I already fixed the 0 just now, so I just need to copy 4 minus p, negative 2 and negative q into my augmented, my new augmented matrix. Okay, so step number 2 is already done. Okay, some teacher said you can do 2 rows. Okay, yes, fine. You can do 2 rows at a time, and you can don't follow the steps that I mentioned just now. It's also fine as long as you get all the rules, the 3 zeros and the ones if you want a perfect row echelon form. Okay, but for me, following the steps and doing row by row is actually playing safe. Okay, so it's up to you to follow what your teacher teach. I have no say to that because some students, they like to do it fast. If you are if you have already been an expert on this, you can continue by doing all the steps 2 rows at a go, and not following the steps shown just now. But if you are still learning, I suggest you follow the steps. Okay, so the third step now, I'm going to transform this to 0. Following the rules here, I need to transform that to 0. So to get 0, I have to think. Okay, so I'm going to fix it first. So I'm going to copy these 2 rows as so, and then I'm going to fix that into zeros. Then I'm going to think, what do I need to do to minus this to get this as 0? Okay, so I will choose row 1 minus row 3. So row 1 minus row 3. Okay, I will get 0. Okay, so with that done, I can directly row 1 minus row 3 from here. I can do mental calculation. So if you are fast, then go ahead. But if you are still learning, then you can copy row 1 and then copy row 3 and then minus them out. And then once you already fix the zeros, and then you copy what is left there in the answer. So I have 1 and 1 minus p, and the last part here is 0. So I will copy it down. So as I say, this yellow box, whatever is in these yellow boxes, are optional. You can choose not to do so and just directly take row 2 minus row 1. Okay, next one. My next target is the 4th step that I mentioned just now, which is here. So my target is to transform it into 1. So to transform that into 1, what I need to do is basically using this formula. So it is easy to just swap these 2 rows, then I will get my 1. Okay, then I copy them all down. So I just swap row 2 to row 3. So I will get my 1 because row 3 I already created a 1 there. Okay, so that's easy. Swapping is easy. Just copy whatever in row 2 into row 3 and whatever in row 3 into row 2. Okay, now my next step will be here, where I need to create a 0 over here. So to create this 0, I need a formula. So I will fix that 0 first. So I have only 2 empty places for me to fill in now. So I will need to think how to get 4 minus p to transform into 0. Okay, without disturbing the 0 over here, because all of this will be fixed. Okay, now the formula that I chose is I take 4 minus p multiply with this one, row 2, and then I'm going to minus row 3. So for equation like this, it will be harder. So I suggest you build that box. Okay, so 4 minus p multiplied by row 2. So row 2 is 0. So 4 minus p multiplied by 0, that will give the first place. And then 4 minus p multiplied with the second is 1. So that will give me 4 minus p. Oh, sorry, here, 4 minus p. And 1 minus p multiplied by 4 minus p. So I will get a quadratic equation as so. Okay, and then 0 multiplied by 4 minus p, I still get my 0 here. So that will be 4 minus p multiplied by row 2. Okay, so which means I'm already, everything is already ready. Minus row 3. So I just copy whatever in row 3 into my box, and then I will minus them. So 0 minus 0, I already get my 0 here, and I already fixed this one too, which will transform into 0. So I just need to take this part here minus -2. Alright, so this quadratic equation minus -2, I will have this, and then 0 minus -q, I have a positive q, and I'm going to write these two answers here into the box. Okay, then I noticed that, wow, the row echelon form is already here. Okay, it's already here where I already have the triangle, which means I already reached the row echelon form. Okay, I already reached my row echelon form because I do not need to transform this to 1. Okay, because I already see this one, the 3 zeros coming out first. Okay, now my first part of the question, the 5 marks, is already done. So I need to go to the second part of the question, which is also the question that Louis Lau asked. Now, in this question, it is asked that it is the value of P and Q, determine the value of P and Q such that the system has a unique solution. So Louis Lau asked why the entry is not 2 and 3. So I'm going to explain that now. So according to the rules that we know, this part over here, which when we have a unique solution, this part also over here can be any number except 0. So it can be any number except 0. So we will write, and this part over here can be any number. Okay, so in that part in the question for unique solution, we will need to write that this part over here, it can be any number except 0. That's why I put it's not equals to 0. Okay, now that we know that it's not equals to 0, therefore my calculation here is going to be p minus 2 and p minus 3. Okay, after I factorize this quadratic equation. Now, once I know that p minus 2 cannot be 0 and p minus 3 also cannot be 0, that's why the number 2 and 3 is not going to be the value of p. Okay, that's what Louis Lau. I hope you understand now, Louis Lau. And then the value of q, of course, because they asked for the value of q also, and we know from the rules for unique solution, q can be any number. Okay, can be any number, so q can be any values in our system. All right, that is part 1, which is the unique solution, and that answers Louis Lau question. But of course, I'm not going to stop there. I'm going to go to the next one. No solution. Let's check it out. When the system has no solution, we know the rule is we have to be 0. This value here have to be 0. And this value here can be any number except 0. Okay, so that is the rules that we have when there is no solution. When there is no solution, therefore, for the case for no solution, we have to write this quadratic equation equals to 0 because it have to be 0 to get no solution. Okay, so now I have put that into the position. I factorize it. Now that I know my p minus 2 and p minus 3 equals to 0, so I will have p equals to 2 or my p equals to 3. But the q can be any number except 0, so I will write the answer as q cannot be 0. That will answer the 2 marks that they give you here for P and Q with no solution. Okay, so that is the part B of the question. Now, in part C of the question, let's see what they want. They wanted to determine the value of P and Q such that the system has infinitely many solutions. So for infinitely many solutions, you know both of these have to be zero. Have to be zero. So therefore, we can write our infinite many solution as P, the quadratic system, equals to 0. So we have the same factorization, and we will get our P equals to 2 or our P equals to 3. So we have both of them. Okay, but then remember the Q. So the Q have to be 0 too. So now we have two sets of answer. The P equals to 2 and Q equals to 0, or P equals to 3, Q equals to 0. Okay, so that will complete the first part of the question. But there is a second part in this question. Okay, there's one over here. Using the value of Q and the smaller value of P obtained, find the solution of the system. So in this second part, we have to choose which P and which Q we are going to use to solve the solution. Okay, of course, the Q is always 0 for the case of infinite many solution, but the P we have 2 and we have to choose the smaller value of P. So I'm going to choose this one. P equals to 2 and Q equals to 0 because they wanted the smaller value of P. So that will be 2. Okay, so let's continue. Now, for this smaller part, okay, remember these two values here, right? For infinite many solution, these two values here have to be 0. And I already chose just now my P equals to 2 and my Q equals to 0. So I know these two placing is 0. So I'm going to adjust my augmented matrix. Okay, so these two here, I'm going to transform to all of them into zeros, and the place for P, I'm going to change with 2. So 1 minus 2, I get negative 1. And then the place for Q, I'm going to change with 0. So that's the 0 over here. So now to solve this system, to find the solution of this system, I need to change this augmented matrix back into my linear system. So as you know, whatever you have over here, the first column represents all your x, the second column represents your y, and the third column represents your z. Okay, so I'm going to change it back into the linear equation. So what we have here, the x will be x plus 2y plus z equals to 0. And the second row is, there's no x, 0 times x, so but there is a y there, and then there is a negative z there. So y minus z, and the answer is equals to 0. Once we reach this situation, then we can find the solution. But this is an infinite many solution. So for a case like this, what we need to do is we take the n part, the values y equals to z, and we will always start with letting z equals to t. Okay, letting z equals to t. Then we place the z into change the placing for the y. So we have your y equals to z, so your y is also equals to t. Okay, we always will start by letting z equals to t. Okay, once we do that, and then we will go for the y, and then we will work into our z. So what will happen here? This will be this will be our Z, and the placing for Y and Z we are going to change to T. So we will end up like this. Okay, so we have 2T because the Z is the Y is T and the Z is also T. For this case, they can change into other cases. So you can try other questions to get the answer. So once we are done with that, then we will move the value, so we will get our X values, right? Once we reach our X values, then we have to write a conclusion for this question, okay? Because the conclusion of the question will be 1 mark. So we will write the solution, because the question asks for it, the solution for this system, the solution of the system are negative, for the place for X is negative 3T, for the placing for Y is T, and the placing for Z is T. And T are all real numbers. Okay? So that's wraps up the question, and that will be full mark. So the full mark is not really hard to get, right? So E is so easy to get. So just make sure you continue subscribing. If this video gives you some good values, please hit the like and share button, alright? And tell your friends about it, because I have seen so many students asking their teachers and asking in a Facebook group about this question. Okay, so now I hope it gives you some kinds of idea on how to solve the question. Alright. So, how was the video? Did you like it? If you do, please hit the like button and do subscribe to my channel if you have not. And there are these videos over here which you can also check out to help you score better. Well, that's all from me today. See you in my next video. Bye!